was the year of 1966 when an elegant and futuristic aircraft was officially presented to the United States Air Force, marking the beginning of an illustrious career that would span more than 3 decades. This plane became one of the most iconic and respected in aviation history, despite never being equipped with weapons. It gained a reputation for being the most feared aircraft of the Cold War thanks to its unparalleled speed and altitude capabilities. It could fly higher and faster than any other weapon in the Soviet arsenal, becoming an invaluable asset in information-gathering missions. Even after its formal retirement in 1998, it remained an engineering marvel and a testament to the ingenuity of its designers. Since then, the United States Air Force has worked tirelessly to build another aircraft that would perfectly replace its predecessor with even superior capabilities. However, it has had little success in this regard. It was only in November 2013 that Lockheed Martin, one of the world's leading aerospace and defense contractors, unveiled the next-generation successor to the State Route 72, the Blackbird's offspring. Like its predecessor, this super-advanced aircraft will be designed with the primary mission of reconnaissance, surveillance, and information gathering, but will come with significant upgrades and improvements. One of the major upgrades is the fact that it will be an unmanned aircraft, capable of being remotely controlled from the ground and never requiring a human pilot. In addition to this being a crucial advantage of the State Route 72, it will also make the aircraft capable of flying at altitudes and speeds much higher than would be safe for a human pilot to withstand. The combined capability of WESTer 2's unprecedented speed and extremely high altitudes, according to the marketing, would make this aircraft ideal for conducting surveillance and reconnaissance missions without being detected by radar or any other advanced tracking system. Despite all of its impressive features, the WESTer 7 remained in prototype stage until the end of 2021, and it was unclear when or if it would enter full production. But all of that changed last year, after sightings of an aircraft that looked like the 7-1, generating speculation that the long-awaited WESTer 7 may have already reached an advanced stage in its development. The STAR project is ultra-secret and is being developed by Lockheed Martin in partnership with NASA and the United States Armed Forces. As such, there is little information available about its development status or when it will be officially launched. It is expected that the project will create a supersonic plane that can fly at speeds of up to Mach 6, or approximately 4,500 miles per hour. To put this in perspective, it would take just over an hour to fly from New York to Los Angeles at this speed. Although the original spy plane Blackbird West 001 was considered ahead of its time, the WESTer 7 will take that legacy to the next level by incorporating cutting-edge technology, including advanced propulsion systems and sensors. It is designed to fly at an altitude of around 80,000 feet, roughly twice the height of a commercial plane. At this altitude, the air is much thinner, allowing for faster speeds and lower air resistance. However, the extreme conditions at this altitude also present a series of engineering challenges, such as managing the heat generated by the aircraft's skin friction. Furthermore, the hypersonic flight envelope is largely unexplored territory. There are still many unknowns when it comes to the aerodynamics and materials science required for sustained hypersonic flight. The extreme temperatures and pressures at supersonic speeds will require new materials and structural engineering approaches. Despite these challenges, the team behind the WESTer 7 is optimistic about the plane's potential. With its sleek design and cutting-edge technology, it is poised to take its place in the pantheon of legendary aircraft like the Blackbird and Concorde, pushing the boundaries of what is possible in aviation. The S-7 is one of the most highly anticipated aircraft under development, and its success is expected to revolutionize the aviation industry. The development of this groundbreaking aircraft is heavily influenced by data collected during the tests of the Falcon 8. The video was an unmanned test vehicle launched by the United States Department of Defense in 2010. Its main goal was to collect data on hypersonic flight and guidance, as well as remote control during the 3 concentrated phases of IT-21 testing. Aerodynamics, aerothermal effects, and navigation control were extensively studied. The results of these tests were crucial to the development of the S-7 project, ensuring that it could withstand the extreme conditions of hypersonic flight. During the exhilarating tests at speeds of up to 21,000 km per hour, thanks to its advanced engines and aerodynamic design, while flying through the upper atmosphere, the temperatures of its external surface exceeded an astonishing 1925 degrees Celsius, which was hot enough to melt steel. The success achieved during these extensive tests provided the confidence and knowledge necessary to continue developing the S-7. Although the flight development is secretive, with very little information available to the public about the aircraft, rumors are now circulating about the advanced and stealth technology with which it will be equipped. From the leaked concept art, it is clear that the S-7 is an impressive engineering feat. It is expected that the aircraft will have an elegant and futuristic design, optimized for high-speed flights. The dual inlet mounted on the underside of the fuselage provides the engine with a constant flow of air, ensuring maximum performance. It is also expected that its thin, low-mounted delta wing assemblies will reduce drag and improve maneuverability at high speeds. While its single vertical tail fin ensures stability during flight, in the same way, the S-7 will be capable of flying at even higher altitudes than its predecessor. For context, the S-7 is expected to have a maximum altitude of around 30,000 meters. The S-7 aircraft is capable of conducting reconnaissance missions over a much larger area, making detection and tracking more difficult. It has a retractable landing gear that allows it to take off and land excessively, meaning the aircraft can be recovered in the same way as a traditional aircraft and kept on the ground for repairs. However, the S-7 is expected to spend most of its time flying at high altitudes, at speeds of up to 6 times the speed of sound, collecting information that would be impossible to obtain using conventional aircraft. The key ingredient to the success of the S-7 will be its power plant, which will be a combined cycle propulsion system based on a turbine. The basic turbine engine will provide the necessary thrust during takeoff and up to Mach 3. When the aircraft reaches these speeds, the dual-mode rangeant will take over, allowing it to reach hypersonic speeds.